Testing audio.
Testing audio.
Okay, that sounds good. Could you explain how to deal with non-equilibrium thermodynamics? What's the difference with the equilibrium version? It definitely depends on. Well, I guess it depends on what you're talking about. I suppose there's so many different little things. Like the equilibrium version is sort of very clean, and in my experience, the non-equilibrium version doesn't really have. Like, to be honest, when you say that, there's so many different things that you might be referencing to. So, for example, you might be looking at something like linear response theory. Now, linear response theory is like, if I'm in thermal equilibrium, how does perturbing it out of equilibrium, what does that look like? So you get things like the Kubo formula. That's something that's pretty easy to look up. And then, there's all kinds of like things like that, like the diffusion equation, the reaction diffusion equation. They come in sort of all shapes and sizes. So I would need to know what you were sort of talking about. Just thinking of a system in contact with two reservoirs of different temperatures. And sort of like what's the setup of the problem? Thermodynamics and StatMech are sort of like weird in this way. Is this like a textbook problem that you're looking at? I have a question regarding learning solid-state physics at an undergraduate level. What would you say are the prerequisites for the subject? I've done StatMech and thermo, along with linear algebra. I would imagine that quantum, both the first and perturbative methods, are needed as well, right? Yeah, you're probably going to want... there's plenty of sort of solid-state physics that you need to do with classical mechanics as well. Like, when you learn that subject, it's almost like a... It's almost like a sort of like a story of failure, like you go through and you try to solve these problems without quantum mechanics first, and it turns out that you just don't get the right results, and so then you need to jump into quantum mechanics. So I'd say being very comfortable with quantum mechanics. You already have StatMech, which is awesome. And you already have thermal, which is awesome. So basically, if you don't have quantum, then quantum is next. And then once you're there, it's sort of like almost like a culture shock. Like, I had all the prerequisites going in, and then it was almost like a culture shock when I got in there, because all the language is a little bit different. But really, that's all you really need. You need quantum, StatMech, thermal, and then you're ready to learn solid state physics that takes you from the classical part to the quantum part. Which book would I recommend? Give me a second here. I will quickly. I forget the book. I wish I included it in that textbook. So it is solid state physics. So the book that I learned is Solid State Physics, the Oxford Solid State Basics from Stephen H. Simon. It's a very good book. It's very detailed. This is, however, the one that I got a little bit of culture shock with. So that's definitely a good one. And then Ashcroft and Merman is sort of a staple of the field. So if the Oxford Solid State Basics aren't sort of fitting into towards what you want, or maybe it's too easy and you feel like you can go a little bit harder, Ashcroft and Merman is sort of the gold standard. Not really, just thinking of a general problem, maybe a gas in a box with two walls at different temperatures. To be honest, I've never done a problem like that. So, of course, the particles in a box themselves would be pretty easy, but then you would want, I would imagine what you would want is, nothing immediately comes to mind, but you would want some type of interaction. So when the balls hit the wall, there is some type of exchange in maybe thermal energy. Maybe I've never done a problem like that, to be honest. There would need to be some type of interaction that can exchange energy on the walls. What's the presentation for? So the presentation is my first ever 45-minute seminar. So I've never given one of these before. I've only ever given like 12 to 20 minute 12 to 20 minute talks, and in those ones you always feel like, super rushed. You feel like you could say more. But this one is I'm giving a 45-minute talk to a bunch of people at Nottingham University, and I think there's some surrounding universities that also attend. It's like a quantum dynamics sort of specific talk. So I'm going to talk about the concentration of quantum equilibration and an estimate of the recurrence time. This is based off of a paper that I recently wrote that's up on Archive. And basically it's, by the end of the talk, you find sort of some bounds to sort of tell you that, once your observable equilibrates, basically with very, very high probability, if you were to go measure your observable at some time, you'd find it at equilibrium. And then using that technique, actually, you can basically say that the Poincare recurrences that I've talked about on the channel, when your system leaves equilibrium and goes back arbitrarily close to its initial conditions, those are like very, very far away. It's like e to the volume of the system. That's how long it takes for those recurrences to occur, based off of our results. It's sort of thank you. Yeah, it's sort of strange going from these very short talks to these very long talks. I'm not really sure, in the shorter talks I usually have a rule of something like, you want about, for every minute and a half, you want about one slide. But I don't know the rule for 45-minute talks, because you can see 45-minute talks and people will have, 16-minute slides. So, they'll have 16 slides, and they'll spend a really long time on each slide. So, not entirely sure yet. I haven't done a complete practice run. See, just send a quick script to a collaborator, and then I'll get back to the talk. Which courses did you find the most challenging in both undergrad and grad school? I heard horrors about QFT. So I actually never took a formal course in QFT. None of the institutions I attended actually offered formal courses. People were expected to sort of like learn it on their own, and then some people, if it was necessary for research, you were sent to the Perimeter Institute in Waterloo to take their course. So the ones that I always found the most difficult were, well, I guess like in I was half split between math and half split between physics, and the hardest course I ever took in terms of how many people failed, and I also didn't get a very good mark, was real analysis. And the reason why it was so hard was they used to have 3 courses. And what they did was they decided to compress it into 2 courses, and for some reason they compressed for some reason they compressed it into 2, and they put most of the material weight into the first course. And this is the one that I was taking. It's my first ever proofs course as well. And I think we started with like 80 to 90 students, and I think only 10-ish people took the final exam because most people dropped it. And then still out of that 10, people failed, which was really bad. And then there were some horror stories in my undergrad for electromagnetism, and it just sort of depended on the prof that you had. I had an easy time, but other people, you'd be like a second year, and the prof would be like, listen, we're going to learn tensor calculus first, and then we're going to do the whole thing in tensor calculus, and then everybody would fail. A grad school one that was tough but very rewarding was advanced statistical mechanics, and this course was basically just the study of classical phase transitions, and you did it all through classical field theory. And so at times it was sort of hard to keep track of what was happening in the class, all the manipulations in lecture. Still have nightmares about real analysis. Yeah, there's something uniquely challenging about that class, especially if you've never taken a proofs course. Real analysis was always... Congrats on the big... Hey, Wyatt, how's it going, dude? The move is... Nottingham's actually really nice. I've never been in like a so I'm downtown right now, and I've never been in like a downtown that has like lots of ease of access, sort of. Like anything I Google, it's like right down, like it's a 1 minute walk. The public transportation is pretty good unless you're at like peak student hours, and then it's like crowded like everywhere else. Um, and Yeah, no complaints. It's a little it's a little cloudy, I guess. Always, I feel like the buildings could use brighter colors because it's so cloudy all the time. So it looks so, with the dark colors on the buildings as well. It looks a little depressing. Um, and my Airbnb is right beside a pub that throws parties, or has people there very, very loud until like 4 or 5 in the morning. But otherwise, beautiful city. I like it a lot. I hear you're in quite the beautiful place as well, aren't you? Like right off the Alps right now. Graham says I'm applying to a new grad program in quantum science engineering. Penny for your thoughts. I think it's a great choice. I think that there's lots of, like, for one, it's a very interesting path to take, and two, so not only is it an interesting sort of science to work in, it's it's been raining for 3 weeks. You can barely see the mountains. So it's a very interesting field to work in, and at the same time, it, like, you want yourself to have good job prospects coming out of of graduate school or undergrad, or whatever stage of your career you're at. And there's lots of money. There's in the field right now. I worked a little bit on looking into this field, and it seems like, one, there's lots of money, lots of startups, lots of good opportunities, and at the same time, it looks like they're actually making real progress. It's raining for 3 weeks. Luckily for me, I mean, the stereotype is that it's supposed to always be raining here. I think it's rained once, and I've been here for like a week, so it's not so bad. Why? What's your wisdom for 45 minute talks? I've never given a 45-minute talk yet. A friend of mine just moved from Innsbruck to Vancouver for a quantum startup. Yeah, it's definitely an interesting time. Sorry, I'm not really showing what I'm doing with the. I mean, perhaps people don't care, but I have a collaborator who desperately wants a Python script right now, and for some reason their Outlook won't let them download it. So where can I put this? Dropbox, yeah. Upload files. Forty-five minute talks are usually for non-specialists, right? So unfortunately for me, This is to like a group of, it's like a quantum dynamics specialist seminar. Superfluids, super solids, BC stuff. Yeah, Wyatt's research is really cool. Innsbruck is ultra cold atom central. Wyatt's research is very cool. We have an article together that has been sort of off and on in the edits for quite for quite some time. We actually need to get it done. Any exercises book you recommend to statistical mechanics? What textbook did you do in your undergrad? Grainer and Pathria. So if I remember correctly, the Berlinski textbook that I recommend in my textbook recommendation, I guess I didn't cover, which ones have a lot of practice questions. That book does have a fair amount of good practice questions. There's a number of good practice questions in that book. Carter, if I remember, I think it was a little sparse on questions, but the questions were long and detailed. So the Berlinski stat mech definitely has a lot of questions that are shorter, and then Carter has longer questions but less. I don't know. I'm a fan of the Berlinski textbook, to be fair. Yes. I believe Pathria does have a solutions manual. And I believe, don't quote me on this, all my books are in storage. I believe the Berlinski textbook has solutions at the back of the textbook. And same with Carter. But for like selected exercises, not every exercise is in the back. Oh, he has available lectures at MIT. I actually didn't realize that. I had never seen that. Wyatt, when you moved to your postdoc, did you just bring a bag of clothes? That's what I did. I basically gave away all my furniture. Oh, that's really interesting. I did not realize that. Yeah. Was it easy to find an apartment? It was like honestly, no one would basically talk to us until we got here. So I have an Airbnb for a month. Yes, yes. Same over there, eh? I guess the other PhD student, Greg, who is on the channel, who moved to Europe for a postdoc. Last I heard, he hasn't found an apartment either in his location. It's very strange. Very hard to get an apartment. You'd think the universities would help you somehow. So the talk is about a recent article I wrote. So the title is Concentration of Quantum Equilibration and an Estimate of the Recurrence Time. And basically, concentration of quantum equilibration says that the, you can guess what the equilibrium value is by just taking the infinite time average of your expectation value. And that doesn't necessarily mean you're actually going to go to equilibrium just because you can write down what the equilibrium would have to be, right? So what we've proved is that, if you sample a random time, then you are overwhelmingly likely to find the observable at the equilibrium value. And so that's really interesting. But you can go even farther than that. Using that result, what you can do is you can then estimate how long it will take for recurrences to take place. So recurrences are, if you haven't seen the Poincare recurrence theorem video that I did, it's basically when you're in equilibrium, but quantum mechanics basically guarantees that you'll eventually go back to your initial state or arbitrarily close to your initial state. So intuitively, if you want stat mech to emerge from your dynamics, then you don't want this to happen until very, very long times. And we're able to prove that. We're able to prove that they happen at e to the power of e to the power of the volume of the system. That's how fast the recurrence time diverges to infinity. My bad. Unfortunately, I don't know anything about time crystals. I see it pop up all the time in the literature, but I've never actually taken the time to read about them yet. Is it coming up in your research? Go back. I see. There definitely seems to be some overlap in terms of people interested in time crystals and people publishing um, more related to my research, but fortunately, haven't haven't looked into that yet. Oh, interesting. So, do you only have time crystals if you have an integrable model? Is that the claim, or the only perturbative inclusion interaction doesn't break the crystal entirely? Cam theory would imply that from a classical point of view. I see. Yeah, I need to. I don't. It seems like an interesting topic. I haven't looked too much into it, unfortunately. How did you get to research at the Perimeter Institute? So I was at McMaster University for my graduate school, and there's a number of profs there that are affiliated with the Perimeter Institute. And I started collaborating with a postdoc at PI, and eventually, like so when you're a student of these professors who are affiliated with the Perimeter Institute, you're basically automatically, like, it's usually just expected that you go there, Tuesdays and Fridays to be at Perimeter, and usually your prof comes with you. But I wasn't with a professor who was affiliated there. But eventually, I was going so much with them because they were already going. I was hitching a ride. Um, and so I asked one of them if they could, sign this little piece of paper that Perimeter, like, it's like a sponsorship basically. So I got sponsored by one of the local profs that was on my committee to become a Perimeter Institute associate graduate student. Because I was already going there all the time for collaborations. Is your presentation related to ETH? In some sense, it is. So the model that we do all the examples in was confirmed in these two articles to obey the eigenstate thermalization hypothesis, or at least it looks like it's converging to the predictions of ETH. And so, well, I'm not directly testing ETH. What I'm doing is I'm testing sort of like the dynamical aspect of getting to equilibrium. Do not understand anything. I've started learning intro quantum mechanics on my own. I am not in any university. Any advice? So what's your background? Like, do you have an undergraduate degree, or like, are you a high school student? Like, I can't really give you good advice without knowing what your background is. But if you're having trouble learning quantum mechanics on your own, it could be a math issue with your background. It could be a physics issue with your background. And it could be just that you need to sort of put more time into it. It's a hard topic to learn. Hello, sir. What's your research topic? My research topic is the emergence of statistical mechanics from unitary dynamics. So closed, isolated quantum systems how do we get stat mech? So, if you've seen some videos on the channel, it's very much all centered around that. So you got like eigenstate thermalization, equilibration, scrambling of quantum information, that kind of stuff. Do you think people do quantum foundation anymore? Is it a dying field? So from my understanding, I haven't looked into this in a few fields, but it's anything but a dying field. There seems to be like a fair amount of research going on. There's still some strong, they might be sparse, but there are strong institutes that focus on it. Is the plan to continue working on ETH things in the postdoc? Yeah, actually. So I'm working with someone who's also working on this type of stuff with like a very different perspective. So like it's definitely not like an easy onboarding, but the idea is that we'll continue I'll continue working on ETH type stuff, but from like a very, he's making a lot of analytical progress on problems that you usually can't make analytical progress on with these like neat tricks that he seems to be pioneering. And I'll continue on working on that. It's lots of things to learn, but similar field, similar topics, similar questions. Sean Carroll has many great podcasts on the foundation of quantum mechanics. Yeah. Yeah, absolutely. Okay. So we track observable A. I don't know, how do I say this nicely? A lot of timescale of these processes, but to be honest, a lot of the analytics are either guesswork or sort of don't work very well. Thanks, man. I like ETH, many body localization, quantum scar sort of stuff too. It's my understanding that they're closely related. Yeah, absolutely, they're very closely related. If you see someone working on ETH, there are people that don't work on these other fields, but usually when you see someone working on ETH, they're also very aware of many body localization and quantum scars, and and all that stuff. So what are some seminal papers / references for this field? So the big review article for ETH, which is called From Quantum. Let me look this up quickly. I forget the first author as well. From Quantum Chaos and Eigenstate Thermalization to Statistical Mechanics and Thermodynamics. This is honestly a huge one to read if you haven't. I feel like most people who are aware of the field have read this. For many-body localization, so the problem with many-body localization right now is I feel like any review article that was written in the last, like, even a year ago, it's sort of like a hot moving topic. It's been a very big topic of whether or not MBL is a true phase of matter, or if it's like sort of like a pre-thermal phase. So I would read newer papers and read those introductions right now about many-body localization to get an idea for that field. And then quantum scars. I haven't seen a lot of quantum scars research recently coming up on Archive, but to be fair, I haven't been very on top of Archive. Hopefully that's somehow useful. Have you read this big review article that I mentioned? I read some, but didn't get too much into them since I kind of had my own stuff going on. Yeah, that's definitely fair. It's difficult to balance your interests with your sort of like desire of, learning this or that. It's definitely a hard line to walk. But that paper is very well written. If you want to get right into ETH, you are welcome to skip. You should probably read the random matrix theory stuff before it, and then you can skip right into ETH. How long should one spend working on a textbook problem? Do I need to solve every one of the problems at the end of the chapter? What should I do if I'm stuck, as I am not in any school/university? So the problem with this. So how long should you spend working on a textbook problem? Textbook problems can take from 5 minutes to an hour to sort of a day to a week. Like I've had problems that really stumped me, and if the problems aren't clicking, then I suggest going for a walk. I suggest maybe rereading the chapter, and if they still don't click, I would suggest perhaps looking at a different resource to reread that same type of topic, and seeing if it clicks. Then you just sort of have to grind at it until you're done. So what I've always done is I usually don't talk to professors or anyone like that. What I usually do is I consult other resources, or I take a walk away from the problem and sort of process the information. Why? How many citations does that have? I don't know how many. Like, what's the? I guess you could go for. 37,000. So I had a professor in undergrad who had a paper that's now at 7,000. Have I seen anything? Have I ever stumbled across anything bigger than that? I don't think so. Like you can look up people with like big publishers in like machine learning, and they have crazy citations. Like it seems like big people in my field have like 50 to 60 H-index. People in machine learning that are big are like well over 100. I imagine they would have. It's the basis. Oh, that makes sense. The basis for density functional theory. Yeah, that makes sense that it would be that much, that many citations. That is crazy. 37,000. What are the highest cited papers? I remember seeing a video about this. Wow, the protein measurement. Oh, I remember this. I was talking to my wife about this, who works in biochemistry. Like these biology and biochemistry stuff, like some of these have like this has 300,000 citations. These are the top 10. Physical chemistry. There's another density functional theory type 1 where it has 46,000. Yes, it was the Simon Clark video. Yes. I remember that now. Yes. I can't even imagine having a paper with that much. good intro to out-of-time ordered correlators. So I would read... this one's tough because I don't know if anyone has fully collected everything into one big source yet. But a really good place to start would be velocity-dependent Lyapunov exponents. That's a really good paper, and it talks a lot about the wavefront of the OTOC, which is one of the key properties that we're interested in it, because you have a finite group velocity, and there's lots of claims about what the wavefront of the OTOC can tell you and what it can't tell you about chaos. And so Wyatt and I have a paper in preparation about that, actually. But I think that's a really good place to start. Wyatt might have a good suggestion too if he's still here. Doc stuff can be scary if people like Douglas Stanford write things. Yeah. Lots of famous people writing papers in OTOCs. It's definitely a hot topic. Yeah. How do you find connecting with friends back home in Canada with the time difference? It is, yeah. I think it's possible because I think the physics really, like what you expect to see changes when you go to like local quantum systems. Yes, Maldacena was using OTOCs. He has this he has a very important paper where he bounds the quantum Lyapunov exponent with the temperature. It's a very key paper in the field right now. Time difference is a bit annoying. It's easy to connect with people on weekends, specifically Saturday and Sunday evenings. Yeah, I agree. It's tough. My wife is now sleeping in as well, which is making things difficult. She's on vacation, so it's fine, of course, but T goes to infinity. Could you explain this to a person with high school physics knowledge about what's going on in that equation? Which equation? Let me go back here. Are we talking about this one here? I see you're in high school. So quantum mechanics is very, very difficult to learn. Have you taken... it's very difficult to learn with the improper background. And so have you taken a calculus course and a linear algebra course? The math you need is calculus and linear algebra. And if you don't have those, I would recommend studying those prior to studying quantum mechanics. And then it would also be good to study some classical mechanics prior, because it does, you rely on that quite a bit to learn quantum mechanics. So the thing that's going on in this equation, though, is that we are just averaging over all time, is basically the idea. I watched your PhD reflections video. What were the books for your comprehensive exam? So I had the Berlinski Stat Mech. And that one was good. And then I had... I had a solid state physics book, but it wasn't Ashcroft and Merman. It was another one that I don't remember the author's names. Let me quickly look this up. And then I had the Quantum Info by Jaeger. And then I had Kittle. No, it was a newer. By Quinn and Yee. Basically, I skimmed through a bunch of the books, and the one that sort of vibed with the type of notation and stuff that I liked, I picked that one. And so this one was quite nice. And then I also had the review article on equilibration and thermalization by Jens Eisert. I don't know if I'm pronouncing that right. Yeah, when something goes to infinity, it just means it's sufficiently big. So in practice, this step here is for mathematical convenience, but in reality, what we mean is that we're averaging over, maybe you could take something like e to the power of the thermodynamic entropy, and think that should be sufficiently long. Hi, Silver. I had Arbeck. I think it's probably an amazing book, but almost entirely impenetrable. What other books did you have? Like, what topics did you focus on for your comps? You had Carter 2 StatMech. Oh, and field theory, eh? I see. Wow, yeah. That's a good lineup. Did you find it was helpful for you? I guess at the beginning I felt like it was very helpful for me, but I sort of got frustrated with being pinned down reading stuff after a while. Not in high school. I'm 28, just trying to learn physics on my own. I have been fascinated by the subject since high school. Okay, yeah, that's a really cool endeavor. So I would definitely recommend, if you don't feel super confident with the math that you're seeing, to go back and learn the math. I know that might sound kind of boring, but if you really want to get into quantum mechanics, then you need to feel comfortable with the mathematics. So I would say, for a first book in quantum mechanics, like, you want to do like sort of a first year type thing in a first year book of calculus and a first year book of linear algebra. Um, and then from there you need to assess, you know, is the material that I'm looking at, like, is that becoming easier, or am I still seeing mathematics I don't understand? Great channel. We need more expert sharing the day to day. Yeah. So if you guys so it was suggested to me yesterday to add sort of an advice slash sort of like a questions section to the Discord channel. And so if you guys have, I do like making the day to day type videos as well. And to be honest, they're almost like easier to make because I just like think about it for a bit and then I talk about it. So if you guys have questions, join the Discord chat, send me those questions, and I will probably either respond to you there, and then make a video about it at some point for other people who who might be looking for that type of advice. Yes, that's true. Yeah, JPH is right. There's tons of good material online. Wyatt was mentioning the MIT lecture series, and there's tons of other people on YouTube making very good courses that you can watch through and follow along. Khan Academy has some decent stuff. It's been a while since I've been appealing to those to that space of YouTube, but I mean, if you just look it up, it'll be easy to find. How do you get into the Discord? So every single video, I believe, or if you just go to a recent video, will have a Discord link at the bottom of the description, and there it's just an invite that you can click and you're automatically in. If you Frederick, I haven't seen them, but I'll take your word for it as a good recommendation. So if you can't, I guess that's kind of inconvenient. I should have added that description. Is it possible to add descriptions? Edit. It is. Okay. I'm going to add that to the description here as well. Yes, I'm a postdoc at Nottingham University now. So I just moved to the UK last week, and so for those interested in I updated. I don't know if it automatically updates for you, but I updated the description, so it also has the Discord link now for a good spot to ask questions and connect with me quicker than if you just comment on YouTube. So yeah, I'm a postdoc now in Nottingham University. Started my official first day is tomorrow actually, and I'm giving a 45-minute seminar on Wednesday. So that's what this talk is about. I haven't seen anyone from 60 Symbols yet, but I want to. I'm not on any email list for Nottingham yet. I don't know how they select people for 60 Symbols. But if I get the chance, you will see my face on 60 Symbols. If you scroll through, it's a lot of the same people. It's like 5-6 people, and they seem to do all of the 60 Symbols videos. With Brady, of course. Congratulations, what questions are you answering? So still on the same path of looking into sort of the emergence of statistical mechanics and sort of quantum chaos in closed isolated quantum systems. Is he super nice from personal experience or just seeing him on camera? I wonder if I wonder if that's the way to go. Maybe once I feel a little bit more comfortable at the university, I'll ask some people who have been around longer what to do, or perhaps yeah. So what's the postdoc process like, especially in theory? I've heard it's quite hard. So my situation was kind of atypical. I think so from people that I've heard from like high energy people, like effective field theory people, I hear their process is quite hard. You can apply to like even 100 places and only really get a handful of maybe interviews. But to be honest, for me, I applied to one place and got it. But it was kind of atypical because it was very late in the year, so the postdoc cycle was like kind of over. I don't really know how competitive the field was, so I don't know if it's actually if it's a reflection of me being a strong applicant, or it was well after Christmas. So my understanding is most postdocs sort of get filled September, October. And then this postdoc was kind of late in the year. So unfortunately, I'm not a super... I think for some fields it's very hard, and for some fields, it's a little easier. It's very field dependent, from what I understand. There seems to be a lot of people and a lot of postdoc money in quantum dynamics, quantum computing, like that kind of stuff right now. And cold atoms, of course. Oh, and the black hole information paradox. I've looked into it. I've talked to, because I've worked on scrambling and out of time ordered correlators. There's lots of people in my field who are directly interested in the black hole information paradox. And so like I don't directly work on it, but I've spoken to a lot of people who do very similar, like they study similar quantities, like the OTOC, the out of time ordered correlator. Yeah, I don't know. That doesn't really answer. So yes, I'm interested in it, but not at a level of like I'm not an expert. I've just I've met lots of people and I've read lots of paper where the authors are studying similar things, but that's not what I study. How do you find balancing your online teaching stuff with work/research? But I'm not allowed to teach due to visa and language barriers, and started a site, but it's in dev hell. I find that it was so the online teaching, if you mean the YouTube channel, the online teaching can be like a little bit of a hassle. Like trying to keep a schedule, and at one point I was publishing once a week, one point I was publishing twice a week, and I was trying to like keep that schedule, and it sort of like got to the point where like research really slowed down. So it's kind of, but I have a lot of fun doing it. So I've sort of settled into, when I'm not super busy, so when I wrote my PhD thesis, I basically didn't do anything with YouTube. So when I'm overly busy, my solution has been to just stop posting on YouTube. And when things are normal, I'm trying to do like one video a week to one video every week and a half. And I find that like that sort of schedule kind of works for my productivity. Like it's a good getaway. Yeah, not obligated by the uni. Yeah. It's you sort of have to like, I think the key for me is that I usually talk about something either that I'm really excited about, or I talk about something that I want to learn. So for example, we were publishing on the Poincare recurrence theorem at the time when I posted that video. And I had never like just formally went through the proof, but I knew I was eventually going to have to like give talks on this and stuff like that. And you should just be an expert, or like you should understand the stuff that you should understand. So, yeah. Will you be moving towards quantum computing in the future, or stick more with ETH, MBO kind of stuff? So I've been looking at, so the current research line with my new supervisor is still ETH motivated. Um, and I still have my other research lines. I'm also now getting more into ground state physics. I have a publication, I have something in the peer review process, and then I have another article in preparation for ground state physics, which is really good, like quantum states of matter. Um, and Along with that, I've been looking at these variational quantum eigensolvers, which I think is a really cool dynamical problem. Like I feel like, I really like the ETH stuff, and it's been a really good gateway to learning like all about dynamics. And a lot of problems that you're solving on a quantum computer are they're basically dynamical problems, in the sense that you're just applying unitary matrices to a state and trying to get something interesting or useful out of it, right? So, yeah. If I keep my eye on this research, and if things get to a point where like I have some ideas, or maybe I have someone that I can collaborate with, and I can help them, I will move a little bit into quantum computing, but it definitely won't be my main focus anytime soon. Main focus still ETH, quantum dynamics, maybe a bit more ground state physics stuff. So this page, another interesting, so just for fun and what are your thoughts on doing podcasts with fellow grad students, postdocs from different physics subfield? So Dylan used to do this, but he doesn't anymore. So I was doing that a bit. So I'm not sure if Wyatt's still here, but why? So if you go back to the streams, there was a time when I was doing streams like semi regularly, and then I got busy. And then to be honest with you, I just felt guilty about asking people to come on the stream. But I think I'm gonna start doing it again because it's fun. It's fun. Like A, it's fun talking to people that show up to the stream, and B, it's fun talking to other people, about their experiences, because there's lots of interesting tidbits. Waiting for my skip the dishes. Yeah, I don't know what. Yeah, Wyatt, you want to come on the stream again at some point? Talk about being early postdocs together, maybe. I think I'm gonna start again. I think it's a good idea. I think it's good content. I think people like it, and I think it's useful for people. Might be fun to talk about this newer stuff. Yeah, absolutely. Hey John, saw you were live and just wanted to drop by to say that I really love your videos. Keep up the good work. You and your journey are really inspiring to me and other folks. Oh, thank you. I appreciate that. I got bored with caustics. I appreciate that, Corin. I will definitely keep up making videos. I'm glad that people have liked these more casual videos, just talking about my experiences recently. Got bored with caustics. Yeah, I'll reach out to you, Wyatt. Maybe we'll do something. Is your group big? No, my group is brand new. So I think there are 3 PhD students. I thought there was 2, and I was introduced to the 2, and then I met another person who claimed to be a part of the group. So I think there are 3. There could be more. I haven't been introduced to everybody. But my prof is new, very ambitious, very talented guy. I'm intimidated by programming in general. How do you suggest I get over my fear of programming? Well, I would suggest that's fair. Like at the beginning, I was also it's sort of like a weird sort of like paradigm shift in your head to get through to like start being comfortable with coding. I think what you have to do though is you just have to pick one programming language. I would pick something easier to pick up first if you're sort of like intimidated by, C++ looks more intimidating than it actually is. So I would pick up something like Python. Pick up a nice editor like Spider is what I use. Spider is spelt like SP, like SPYDER, and then I would just do tutorials, run your code, see what happens, get the intuition for like for loops, while loops, and just do it. Unfortunately, you just have to do it. Like I learned Python first, got a little bit under my belt, and then it was just when I took a course in C++. Oh no, sorry. The first course where I really started getting stuff under my belt was MATLAB, and they just had like easy exercises to do. Like print out the first 10 natural numbers. Compute this sum, kind of thing. You start with easy exercises and work your way up. I do need to get back. Yes, giving yourself a problem to solve, and then, like as you go through, like you just play with things. Like if you see sometimes you have a problem to solve, you can Google like a portion of the problem, or like if the problem is simple enough, you can just Google the solution to the problem. You see what other people are doing, and then you toy around with their solution. What happens when I change this? What happens when I change that? And then you slowly start building up intuition. It's definitely like a different world, I guess, or like a different way to think about things. But it really helps you structure yourself as a thinker, which is nice. Eventually you'll be programming assembly like John. I'm not there yet, Joe. I would imagine, Joe, that you're a better programmer than I am, to be honest. Joe, don't you work on like crazy big codes? Oh, is there really, with a nice emphasis on programming, eh? Touch like 0.1% of the code bases. I don't know what it is. Like reading other people's code and understanding what's happening is honestly a skill that I just don't have. I know what my code's doing. I can read my code. Reading anyone, like it's just a foreign language. It's like alien script to me when I read other people's code. Does your research require to know the density matrix renormalization methods, or DFT? So I've read about DFT. I don't know DFT very well, but I have used DMRG for recent projects with studying ground state physics. Thankfully, Athena was incredibly well documented and well written, easy to read. That's nice. I usually deal with the Eigen C++ package, and I don't know if you would call that well documented. I think it is well documented because like everything has a page for it. But I don't know. I much better off for me to like go look at an example than to go read like, class constructors and things like that. Gave up the Astrolife. That's fair. Do you think you have coding in your future, Joe? Oh, thank you. I will definitely continue uploading more videos. There's lots of stuff. There's lots of stuff planned for sure. I just have to find the time, which I seem to have a lot more free time now. Focus on teaching for now. Yeah, that's fair. I guess if the teaching permits, or if the class permits, you can throw some coding in there. I had profs in undergrad who insisted that any course that they taught would turn into like there would at least be some coding component in it to get the students more exposed to it. Even if it's something like super simple, like forcing them to install Python and running a script you wrote. I think a third year E&M prof basically did that, where we were given a script and then we were sort of like told in words how to finish it. What is my favorite qubit/quantum memory device? I don't know if I have one. When I was looking at variational quantum eigensolvers, the IBM was publishing lots of papers in that space. Oh, thanks, Joe. Have a good day. I think I should be packing up shortly to go make myself dinner as well. It was nice to see so many people join the stream, though. I'll definitely do these more often, just to chat more, and I'll see if I can get people who want to talk about physics or their experience in physics on the stream. It's been going for about an hour and a half. So actually, I think I'm getting kind of hungry, guys. So I am going to call it quits for this stream. But I will think of other nice things to sort of do in the background while I'm streaming and talking. Which university did you go to for undergrad and PhD? So undergrad, I was at Western University in London, Ontario, and for PhD I did it at McMaster University, which is down the road from London in Hamilton, Ontario. Please do them more often. Yeah. I enjoyed. To be honest, I sort of logged on today thinking no one was going to click on it, so it's nice to see people are down to chat, join the stream. So, all right, everyone. Well, regardless, I don't know if it's morning, evening, or afternoon for you guys, but have a good rest of your day, and I will